everyone, welcome to the first video of our weekly essentials. So weekly essential number 1 is going to cover dimensional analysis. You should have received a worksheet from your teacher, from your math teacher, with 5 questions on it. This worksheet will be due in a week. Then you will take a little mini review quiz covering the same material, okay? We're starting to review for our end of course test, so this is important. So let's look at these few problems. It's dimensional analysis, so we're doing conversions here. So the average weight of a UGA lineman is 312 pounds. How much does one weigh in kilograms? So I always start by writing whatever I'm given. So I'm giving 312 pounds. I'm going to leave some space, come over here. I want to write it in kilograms. Okay, so that's my ending value. I have my starting value and I have my ending units. Okay, here it gives us the conversion we need. So you have this in case you lost your conversion sheet. We know 1 kilogram is 2.2 pounds. So I'm going to put pounds at the bottom so they can cancel. Then I have kilograms at the top. I know 1 kilogram, so I put that by kilograms, is 2.2 pounds. This equals 1 because 1 kilogram does equal 2.2 pounds. Now, I'm going to go ahead and cancel the pounds units. Now, the only thing I have left are kilograms at the numerator, and that's what I want. So now I can multiply straight across. 312 times 1 is 312. 1 times 2.2 is 2.2. And then here I need to divide this. 312 divided by 2.2 is 141.82 kilograms. All right, so number 1 was just a basic conversion, okay? Number 2, Shane bikes 5 miles to the park in 30 minutes. What is his average speed in feet per second? So now we have a rate because we have miles per minute, feet per second. Okay, so we're starting with 5 miles in 30 minutes. Okay, we're going to come over here. I want my final answer to be in feet per second. Okay, so if we look at the numerator's in miles, I want it to be feet. So I have to convert miles to feet. So we're going to ignore the minutes right now. Let's just focus on the numerator. Miles has to go in the denominator, feet at the top, and I have one conversion that I know of. 1 mile is 5,280 feet. Go ahead and cancel the miles here. So now we have just set it up where we're going to convert miles to feet. So now we have feet in the numerator, and that's what we want. So we're done converting the numerator. Now we need to focus on the denominator. So we have minutes. We want to go to seconds. Well, good thing you know that there are 60 seconds in 1 minute, right? So y'all knew that 60 seconds is 1 minute. So minutes are down here. I need them up here, and seconds go here. So 1 minute is 60 seconds. Cancel the minutes units. Multiply straight across. 5 times 5,280 times 1 is 26,400. Divided by 30 times 1 times 60, we get 1,800. And then I can divide this. 26,400 divided by 1,800 is 14.67 feet per second. So if you're going 5 miles in 30 minutes on a bike, you're traveling at 14.67 feet per per second. Now, at any point in time, if you need to pause the video to figure this out or rewind, make sure you do that, okay? All right, the cost in dollars of a single-story home can be approximated using the formula C equals KLW, where L is the approximate length of the home and W is the approximate width of the home. Find the units for the coefficient K. So we know C. So what I want to do is I'm going to set this up. I know this is C equals K L W, right? And this is all multiplication here. So C equals KLW. Well, what is C? C is the cost in dollars. So I'm going to just put a money symbol there. So the units for C is dollars. L is the approximate length of the home. And W is the approximate width. So we're going to say that, I guess it should probably said here, but we're going to say the length is feet and the width is also feet. Okay? Okay, so K is what we're missing here. Okay? So right now we have dollars equals K times feet is feet squared. Okay? We want to solve for K, so we're going to divide by feet squared. So the units for K are dollars per feet squared. Okay, another way you could have thought of that is if you solved for K first. So we have C equals K LW. We want K by itself. Divide by LW. So you get K equals C over LW. And then replace C and LW with the units, which is dollars per feet times feet, which again is feet squared. Okay, so that's how we find the units. Now, number 4, a rectangle has a length of 2 meters and a width of 40 centimeters. What is the perimeter of the rectangle in centimeters? Okay, we also need to know what the word perimeter means. That is the distance around something, okay? So we want the total length of all these sides, but I need it in centimeters. Currently, we have something in centimeters and something in meters. We can't add those together right now. They're not common units. So it wants the whole thing in centimeters, so I need to change 2 meters to centimeters. Okay, so that's my goal right now. So I'm starting with 2 meters, and I want to know how long that is in centimeters. So it gives us a nice little handy-dandy measurement here, or conversion here. I know 1 meter is 100 centimeters. Okay, meters cancel. 2 times 100 is 200 centimeters. So I know this side length that's 2 meters, the same thing as saying it's 200 centimeters. Now we can find our perimeter. Okay, again, here's 40. That occurs twice, so 40 times 2 plus 200 times 2. So this is our perimeter, which is 80 plus 400, which is 480 centimeters is our perimeter. Or instead of doing 40 times 2 plus 200 times 2, you say, okay, well, this side's 40. That means this side is also 40. If this side's 200, this side's also 200. And then just add them all together. 40 plus 200 plus 40 plus 200 also equals 480 centimeters. So the tricky one, or the part about number 4 that might have been tricky to you is converting them to the same units before you found the perimeter. All right, number 5. Kelly can run 1,600 meters in 5 minutes and 28 seconds. If each lap is 400 meters long, calculate her lap time in seconds. So this one's got a few parts to it, okay? We want to know, so Kelly's running this race. Um, she's running 1,600 meters, and this is the time she runs it in. Well, let's talk about how much total time this is. We want it all in seconds, so can we convert 5 minutes and 28 seconds to all seconds? Which means we need to take 5 minutes and convert it to seconds. So 5 minutes, I want seconds. In 1 minute, there is 60 seconds. Multiply straight across, that is 300 seconds. So 5 minutes is 300 seconds. But 5 minutes, so this is 300 seconds plus 28 seconds. So this is a total of 328 seconds. So Kelly can run 1,600 meters in 328 seconds. Same thing as 5 minutes and 28 seconds. Now, let's finish the question. It says if each lap is 400 meters, how long is her lap time in seconds? So she ran 1,600 meters in 328 seconds. How long will it take her to run just 400 meters? Okay, so what you can think about here is how many 400s are there in 1,600? If you do 1,600 meters divided by 400 meters, that's 4 laps. So to run a 1,600, you're running around 4 laps. So we want to know how many seconds it's going to take her to run 1 lap. So we're going to take our 328 seconds that it took Kelly to run 4 laps, and we're going to divide it by 4 laps. So 328 divided by 4. So she ran 1 lap in 82 seconds. So 82 seconds per lap. So we had to figure out the total time in seconds and then figure out what the question was asking for. Okay, again, if you have any more questions on this, please make sure to ask your teacher, talk to your teacher about the question before the day you take your review quiz. And good luck!